Bismillah ar-Rahman ar-Rahim. Inshallah, we'll start 4.7, which is optimization problems. Mainly, these are applied optimization problems or real life problems. So they are word problems. So as usual, when we dealt with the word problems, we need to read the problem. What is given, what is unknown to be optimized. At the end, at each question, what we want to do, we want to optimize something. We want to maximize or minimize a function. That's in each question. You need to maximize something or you need to minimize something. As usual, sometimes we'll draw a picture, we'll introduce variables. Then we write an equation for the unknown quantity. If you can, make it of one variable. As a function of one variable. Then we'll see what to do. But I need to find what? The absolute maximum or absolute minimum in these questions. So I have to maximize, so I am looking for the absolute maximum, not locally. And I want to minimize, I want also to find the absolute minimum. Okay. Now, how to find the absolute minimum, absolute maximum in general? How to find them? Up to now, the only method we discuss was in section 4.1 when I have continuous function over closed interval, where what I will do, I'll find the critical numbers, then I will find f at the critical numbers and f at the endpoints. The largest will be the absolute maximum, the smallest will be the absolute minimum. This is the only one. This is the only method we discussed before. Another way, if we can graph the function, for sure. From the graph, you can see if there is an absolute maximum or an absolute minimum easily. You can see, is there something bigger than all the other values or smaller than all the other values? So I'm looking. The third way, which is new, is this one. By the way, this is not, it is not in the book. So what's the idea here? The idea there is if you have a critical number, C is a critical number, and before C, I have f prime positive, and after C, I have f prime is negative. For sure, C will be local max. However, it's not only local max, it will be an absolute max. If there is only one change for C, there is only one change. Before C, for sure, the function always positive. I'm talking about f prime, huh? The sign of f prime. If f prime is positive for all x less than C, and f prime is negative for all x greater than C, then it's an absolute maximum. And the same thing for the minimum. The local will become absolute if there is only one change in the function. Okay, so these are the three methods if we want to find the absolute extrema. Okay, now let us deal with these problems. Okay, what we have in this one, we have a manufacturer wants to design an open box. I want to design an open box. Okay. Open box. Okay. Having a square base. The base is a square. So if this is x, this will be x. Okay. The surface area of the box is 108. Okay. What dimensions will produce the box with the maximum value? So I want to maximize the volume of the box. Okay. Now, if this is x, this is x. Let me call this h. So it will be the volume of the box. It will be x squared h. Yeah, length times width times height. Okay. Now, this function v, I want to maximize. This is what I'm trying to maximize. I need to find the absolute maximum function. But notice this is a function of two variables. So I want to get rid of one of these variables. Then I will use the other information, which is saying the S service area of this function is 108. Okay. What is the service area? The service area will be this one, which is x squared. Then I have 4 of these, which is xh. One here, one there, one there. So I have 4 of it. Since it's an open box, the box is open. They said the open box. So this is my service area, and that should be equal to 108. Very clear from here, h will be what? 108 minus x squared over 4x. In other words, it's 27 over x minus x over 4. So I plug it here. So I have x squared, 27 over x minus x over 4. And that is what? 27x minus x cubed over 4. Okay. That is 27 over x minus x cubed over 4. That's what I want to maximize. Okay. If you remember, we said we have 3 methods to find the absolute extrema. In this case, for sure, I'm looking for the absolute maximum. Okay. So if I can make it over a closed interval, that's like what we did in 4.1. If I can graph it, or if there is only one change. Okay. Can I make x bounded between two values? Look, x cannot be less than 0. So for sure, x will be greater than or equal 0. This is the smallest value for x. Yeah. Maybe someone said x cannot be 0. Yeah, I agree. It will not be a box, but from a philosophical point of view, x, yeah, we can make it 0. It will not be a box in that case. Okay. Now we'll move to when x will be bigger. X will be bigger if h 0. Same idea. If h is 0. If h is 0, then I have just only a flat thing, which not a box still, but yeah, we can deal with it this way. So if h is 0, so I have x squared plus 4xh equal 0. That will make x the biggest things. If x is 0, I have x squared equal 108. So I have x equals square root 108. So x cannot exceed 108. So now I want to find the absolute maximum. That means what I'm looking for. I want to find the absolute maximum of this function over this interval. What is this? This is a question in section 4.1. It's similar to a question in section 4.1. Which what we will do, find f prime, then find the critical numbers, then find f at the critical numbers, find f at the endpoints. That's it. The largest will be the absolute maximum. The smallest will be the absolute minimum. Actually, I'm looking for the absolute maximum in this case. So this is now my problem, this problem. Now I change it into a problem in section 4.2. Okay, let us do the calculation. F prime will be what? 27 minus 3x squared over 4. Make it equal to 0. So we have 108 equal 3x squared. So that means x squared equal what? 36. So x will be 6. Yeah, for sure, x cannot be negative. Also here, x cannot be negative. So I'm dealing with positive values since these are sizes. Okay. Oh, these are dimensions. Okay. Let me give me more space. Yeah, it's for the first problem. I'm doing it in details. Okay. Now I have x equals 6. And what is f prime? Let me write f prime. Okay, I don't need f prime. I need, yeah, make it equal to 0. That'll give me x equals 6. So now we need to check what is f. Actually, I need f. F is what? 27x minus x cubed of 27x. Okay, so I have this over 0 square root 108. Okay, so I will check f at 0, f square root 108, f at 6. The largest will be the absolute max. What is f at 0? 0, 0, that will be 0. F square root of 108, that will be 27 root 108 minus 108 root 108 x cubed squared and then over 4, which is 27 108 minus 27 108, which is 0. F of 6, if you do the calculations, let me give you the numbers. Yeah, F of 6 will be the number. Yes, 108. If we do the calculation, f of 6 will be 108. So for sure, I have an absolute maximum here. Absolute maximum 108 when x equals 6. Now let me go back to the problem. What they want? They want the dimensions will produce a box with maximum volume. What are the dimensions of this box? It will be x times x times h. So I need x, x, h. Okay, I know x. How can I get h? H will be, I will use this formula to get h. So it will be 108 minus x squared, 108 minus x squared over 4x. That will be 108 minus 36 over 24. That is what? 64 and a 72 over 24, which is 3. So the dimensions are 6 by 6 by 3. Okay. Sometimes maybe they will ask you, find the sum of the dimensions. So it will be 15. Or the product of them, or the volume. The volume will be 108, the maximum volume. At what time, or at what x values, or at what height, with all of these questions can be there. So this is the first one. I think it's very clear. As I said, now we change the problem into finding absolute maximum of a function over a closed interval, which is we did in 4.1. Okay, another problem. You have a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. We have a river, and they want to fence an area. What are the dimensions? Still, that has the largest area. I want my area to be largest. So I want to maximize. Let me put dimensions. I say this is, if this is X, I'll call this Y. So this is also X. River, I don't have nothing, huh? He said he needs no fence along the river. Okay, I want to maximize the area, which is A, which is X times Y. This is what I'm looking for to maximize. Okay, what else I have? I have the fence is 2,400. So the things which I will put here is 2,400. So I have 2,400 equal to X plus Y. Now I have this function is function of two variables. So I need to change Y, or I mean, change one of them. Y will be easier. 2,400 minus 2X. So that means A is what? X 2,400 minus 2X. And that is 2,400X minus 2X squared. Okay. So this is my function, which I want to maximize. I want to find the absolute maximum of this function. Yeah, by the way, this is a parabola. So for sure, it's a parabola opens downwards. So for sure, the vertex will be the and the vertex we have the absolute max. However, let us do it in a different way. Can I bound it X? Yes, I can say X greater than or equal to 0. Same idea. This will be the smallest value of X, and the largest value of X when it will happen when Y equals 0. Y equals 0, I have X is what? 1,200. By the way, if Y equals 0, what I have? I have only one. Yeah. Yeah, but now I can say X cannot exceed 1,200 because if it exceeds 1,200, if it exceeds 1,200, then Y will exceed 2,400, which is cannot be. So X will be that the smallest or the largest value for X is 1,200, and the smallest value is 0. Okay. So it means we are now looking, we are trying to solve this problem. Find the absolute maximum of this function over this interval, which is 4.1. So let us do the calculation. A prime will be 2,400 minus 4x, make it equal to 0. So I'm getting x equals 600. What I will do, just as we did with the previous one, we'll check f at the end points. F at 0 will be what? 0. Actually, from here it's very clear. And f 1,200, that will be 0 times 1,000. That will be 0. And f of 600 will be what? If we do the calculation, that will be 600 times 1,200, which is 7,200. Here we have the largest. So we have an absolute maximum. Depends what they want. If they want the largest area, it's 7,200, which is the absolute maximum. When x equals 600. By the way, if x equals 600, what will be h or what will be y? Just plug it here. plug it here. 2,400 minus 100, 1,200, that will be 1,200. So the dimensions are what? 600 times 1,200. If you ask about the largest area, that will be 7,200. Okay, it depends on the problem. I think it's very clear. Find two numbers whose difference is 100 and whose product is a minimum. Okay, I need to find two numbers whose difference is 100 and whose product is minimum. Okay. So I let these two numbers, X and Y. Okay. Then the difference, I have what? The difference, X minus Y is equal to 100. This is what I get from this. And I want to minimize, the product, which is X times Y. Since it's a product, it's function of two variables, I want to change it from here. It's very clear that Y equal X minus 100. So it will be X times X 100, which is X squared minus 100X. This is a parabola still, and it's open upward. So for sure it has an absolute minimum at the vertex. Okay, but let us do it. Okay. Now, first, can I say X should be between this and that? I don't think it will be easy to do this. So what I will do, I will just try to have one of these two problems. Actually, it will be this case. Okay. So I have to find the absolute maximum, minimum, sorry, absolute minimum of this function, call it p of x, which is x squared minus 100x. Okay, so what I will do, I will find b prime. That will be 2x minus 100, make it equal to 0. So I have x equal 50. So if you have the sign diagram, that will be 50. And I have, this is the function, which is 2x minus 50. That will be my b prime. So before 50, that will be negative, and this will be plus. Notice I have only one change. There is only one change. So this is the local minimum and also absolute minimum, since there is only one change. So I have an absolute minimum when x equal 50. If x equal 50, what will be y? We'll use this. Y will be 50 minus 100, which is minus 50. So what are the two numbers? 50 and minus 50. Okay,